So let's continue with our stuff. I spotted some issues in our hardware, in our virtual hardware implementation. So the problem is that we cannot have rotations like any arbitrary degree of rotation because of the pixel perfect collisions. So we would need to rotate. Basically we have two sprites, and it's easy to do pixel collision when they are not rotated. They can also be rotated 90 degrees and it's still okay. It's easy to do it, to do the pixel collision. But when you have an arbitrary degree of rotation, that's when you'll have to do it really. It's a bit harder because in a very naive way you should rotate the pixels to actually check the collisions, and it's very time consuming, and you'll probably need some lookup tables for the sinus or cosinus angles. So to keep up the traditional way, we will just have maybe 90 degrees rotation maximum, like this. So we can do mirroring. So we'll have flipping and one single 90 degree rotation. So after that you can do like flipping the sprite, or like this if you have it. If you have a sprite like, let's say it has something here. So you can have flipping and rotation at 90 degrees only. Let's modify the specs. Needed spy rotation of 90 degrees only. Scaling, I mean, if you scale the sprite, you can also check collisions relatively easy because you just multiply the number of pixels tested when you fetch the pixel from the sprite. So it should be okay. It's not really needed because I don't really see too much scaling in the old games. You could just do some animation, like scale them back down. Let's check the Dodon Paki.
If you write anything on your computer, you need to get Grammarly.
I write pretty much all day.
Okay, so you have the shadow probably is something. I think it's the same as the mask and it's scaled or something like that. Same for the tank. So the only scaling you have, like, I don't know. I think they have just uniform scaling. I'm thinking now on what you would need non-uniform scaling. But I think we can have it. but I don't know. Let's just have just uniform scaling. I think it's enough for our game. I don't see any non-uniform scaling around here. Yep. Alright. What is it? Okay, scaling. Uniform sprite scaling. Sprite flipping from X and Y. Max sprite size is not really needed. Yes, no texture filtering. We can use a custom bitmap for the sprite collider, because for example in some games you have the ship, but it doesn't really collide with the exterior of the ship, only when the other sprites are reaching the core of the ship. So basically they have some kind of custom sprite for that collision. But we can fake that by having a unit with the body of the ship and another unit with the actual core of the ship with some animation or whatever. And the body of the ship will have the neutral theme, so it doesn't collide with anything. And the actual core of the ship will have the player theme. So it will only that will collide with the enemies. So the ship body will not collide. Yeah, we can fight that. Should be fine. Alright, what else? Let's check this done. Okay, this was done. Keep only flipping of sprites. Okay, we did this too. Yeah, we have to rename the unit to unit instance because to keep the naming consistent. So we had sprite instance, we had the animation instance, and we also have unit instance. So unit template will be just called unit, and this will be called unit instance. It's better. And these are unit instances. Alright. It should be better unit. Just another unit. Pointer. Okay, and about scaling and stuff like that, let's take it from here first. Okay, this is okay. Sprite animation. Okay. Sprite instance. Scale. The scale will be just a float. It can be even some int because everything is pixel based, but we can have probably better scaling animation if we keep it sub-pixel. So it will be just scale 1 and rotation. Maybe you can have minus 90 degrees and plus 90 degrees. Then it can be a simple Okay. Okay, so if okay, so I have dual not mirror, flips, flip around, or flip vertically. How should we call it? A vertical flip. Just to be clear about it. We could make it a float, but vec2, but whatever. And horizontal flip, just to be clear. And I think we can copy this to unit. So we have the unit. Yes. Okay. Actually, we could have kept the. It's okay. Same here. I could make a structure actually for this. Unit transform or something. I could put it here actually because it's the same. Okay, then we call it just transform, and we have this, and we'll put it in our types, or not types. Let's make a new file. Transform. Okay. Where is it? Namespace engine, and there we have include vec2 and also types. Rotation. Alright. If it's minus 90, yeah, let's put it just for the sake of it. Minus or 90. Minus 90 or 90. Vertical flip, horizontal flip, scale, position. So this is a transform, and we'll use it all over the place where we need it. We need a transform. Like for example, right here. Transform. We have it in transform. Alright. This, and this. Okay. Then we have the sprite instance. It also uses the transform. Here. Nope. Transform. We also don't need the animation scale. It's uniform, the rotation, the visibility. What else can we animate? Okay. So the problem here is that we need animation number also, because for each track we can have many. Maybe we can put them in some kind of structure. So we load the unit and we don't need dynamic info or dynamic arrays. Let's see. So a unit can have multiple animations. I think we can do it like this, even if it's a bit too much, but whatever. Animation set. No, animation actually. Wait, animation. Because this is a single track, because we animate only one float value. How do I call it? Yeah, we need to rename this. Because this is called actually track animation. Or even parameter animation, I don't know. Let's make it generic. Animation key, animation track, animation track instance. Alright. And some animation. Animation track and animation which will contain an array of animation track instances. I think. So animation track, structure, animation, okay, which is containing animation tracks. But these should have some names or something like that, or types. I would, because you have like position X, position Y, scale, what else? Scale, visibility, even vertical flip can be animated. Maybe it should have some global enum that holds the track types, so you don't look up by name. So we can have like animation track type, and because we will not have that many track types, animated things. So we have like position, position, scale, rotation, visible, flip, vertical flip, horizontal flip. This will be like 0 or 1 boolean animated keys. Visible, what else? We can animate also the shadows, shadow scale, offset. Okay, so as shadows, shadow scale, shadow offset. Good, because we can like make some animation where the ship is landing and the shadow will be closer to the ship because of the, you know, the parallax, and also the shadow can increase in size or decrease because of the altitude. So we can animate that in some intro animation or whatever. Boss, enter, boss, exit. Alright, we can also put a count here to know how many items we have. That's pretty much it. I mean, I don't have that many. I could also animate color, the tinting, the hit color, but I don't think it's needed for now. Alright, this is an animation track. And so we'll have a STL unordered map with the track type, so animation track type, and the actual animation track, which will be a pointer, and its tracks. And the animation will also have a total time in seconds, total time of the animation, and a predefined speed, which we can modify. Speed, which is equal to 1. Let's also include unordered map. Actually, total time. So the keys have the time is normalized for the entire animation time, but the animation itself, we should specify how many seconds it lasts, and we multiply with the speed. Okay, I think it's okay. And an animation track instance is the one that will hold the keys. Actually, let's think about how we animate a unit. What do we actually call? So we need in the unit, we need some animation stuff. So unit, we have the sprite instances. Okay. Can we animate the sprite instances? Make them move and stuff like that? Yes, we can. So we also have animated sprite instances. So we have animation instance, which will make for each yeah, this is getting interesting. For each sprite instance, we can animate them, right? And what do we need for that? We will need an animation for each sprite instance. Okay. But we want to play a big animation, which will include sprite instances and also children animation. So we will need sprite instance animation which will hold the sprite instance pointer, and will also hold animation. So an animation for this particular instance. And we had animation, which we already did. Yeah, this one. Animation. This is the animation, yes, that's actually. we don't need time, so it animates, and let's have tracks. So basically what we'll do when we want to animate some position, for example, we do like we'll have an let's just try to do like this animation. This is an example here. Instance animation of the animation, yes. Tracks, animation track type. We want the position to interpolate it, to animate it, and we give it animate at time, I don't know, some time, yeah, okay, like this. And what it will give us, the actual position, the animated position. I think that's pretty much it. Yeah, that should be okay. But we also have the speed of the animation. Actually, I don't need speed here. Yes, so this is total time in seconds. I don't need speed here. Speed will be here, or time scale, something like that. Time scale. It's better. Total, we know it's total time. It's time in seconds, or not? No, total time in seconds. It's more clear. Total time in seconds, and we have an utility function here. Animate what parameter? Animate track type. The track type. Time. Okay, and we can take this animation instance, animate track type at time. And we basically return animation tracks, what track type, and at time, but we multiply with time scale. Okay. Yes, we multiply with time scale, so we get a scaled time if you want, like slow motion or whatever. But should be this time in seconds or the normalized time? Let me think. When we animate, yeah, this is an instance. So we also have f32 current time, and this shouldn't be, it should be like this: void update f32 delta time. So we update this instance of the animation, and this will be like animate track type. We already know the time because it's the current time. And we will do like this: animation instance update. Okay, current time plus equal the delta time multiplied by speed time scale, yes. So this is in seconds, everything is in seconds. And now if we have to check if that we got to the end of the animation, but we have three cases actually of animation: switch animation, type, yes, not too much, type. So when it's normal, we'll have if current time is bigger than the animation total time in seconds, then we have to rewind current time equals 0, and we rewind to the first second, to the 0 time. And that's about it for that. For the reversed one, if current time, okay, we also have something here like this: current time, okay, when is normal, when is reversed, current time minus just a second. Okay, so when this is normal and when this is reversed, we go back in time, so it will be inversed. So if current time is less than 0, we make it total time, animation total time, so we get back to the end, to 0. And we also have the ping pong. How can we make it work? I think we'll need some kind of direction. When f32 ping pong direction, let's start is pointer, so it's to the from 0 to total time. So current time plus delta time plus scale or ping pong direction. If current time is less than 0, then we do current time equals to 0, and we do ping pong direction equals 1. if current time is greater than animation total time seconds, we are now reversing the ping pong. Okay, current time equals this, and ping pong direction equals -1. So we are now going from total time seconds back to 0, and this should do the ping pong thing animation. Probably we should start on the graphics, but I'm into the animation now, maybe to finish it, I don't know. Okay, so animate this, or yeah, it's okay, animate, and the time is the current time, but we already have it scaled, so we don't need this. This should be okay. And animate, so we basically have to interpolate 2 frames. Okay, so we have to find the first frame. Let's do it brute force, and then we can optimize it later if it's needed. So let's find the first frame, which is which time. Okay, let's do it. Okay, keys and key count. Okay, so from 0 to key count. If the current key is the current key time is actually we have to let me think a bit. If the at time is greater than time, then we found our key. Our first key. So this is our first key. Animation key K1 is this one, and if I is less than key count, that is null. Key 2 equals actually have to be minus 1. Key 2 is keys. So we have to find the 2 keys which our current time is in between. So we have like key 1 at time is in between the these two keys, so we can interpolate them. Let's see if it's like this, for example. So this time should be like less, and this one should be greater than our current time at time. And we can leave it here. Alright, so I plus 1, so the next key. Else, if it's equal, actually no, should be okay. Okay, yeah. Key 1 and and key 2, and I can interpolate. And how do we interpolate? So we have time 1 and time 2, and we need to find a normalized yeah, for the animation we can even do spline animation, but I don't know if it's really, at least for now. We can modify it for spline animation later. So I need to find the normalized time. Or t, it's better. This should be, let me check. Yeah, we'll need to normalize it here also. Actually, current time to total time, right? So we get a normalized time in the track space. This should be better. Total time in seconds. Yeah. So if the current time is equal to total time, it will be 1. If it's 0, it will be 0. So it will be like normalized from 0 to 1. Because here we are doing 0, 1 time. Okay. Now let's find the actual interpolation between these two values. Okay, so we have the length, which is given by key 2 time minus key 1 time. This is the length of the in time of the segment, and we have to divide the okay. The actual time to get the key, and then we just return key 1 value plus we basically interpolate, linear interpolation, key 2, hope it's correct. We'll check it way later. Value minus key 1 value. So it should interpolate the values, I think. Probably here is minus. Maybe we should. So if the time is equal to key time, then this will be 1. If at time is equal with key 1 time, so this will be 0, it will be 0. Should be okay, I think. Alright, that's pretty much for the animation track. Very simple animation track. Maybe later we can extend it to Bezier or B-spline stuff. But I think just simple linear animation like a polygon moving ship and stuff. We'll see. Because it should be kind of hidden from the. If we do Hermit splines, we don't need any other parameters for the functions. Should be hidden for us, for the user, when we'll extend it. Okay, that's pretty much it for the animation. One more look. Animation track, animation keys, okay. The animation itself, an instance of the animation, because you can have many. For many sprites or whatever. The type of animation playing. You can have also a function that restarts the animation. Or reset, I don't know. Reset. That will just set the parameters to. So what parameters do we have? Yeah, we have to check the repeat count also. So this will be reset. Just like this. And also let's tackle the repeat count. That would be interesting. And we'll have current repeat count 0. And when we update it, if this reached the so current repeat count equals 0. So in normal mode, when we get to the end of the track of the animation, we have to ask ourselves if the repeat count is 0, then it's infinite. We don't do anything. It will just run again. And if the repeat count is different from 0, current repeat count plus plus. Okay. And if repeat count, okay, here actually. So we have to have should we put some kind of active for the animation, or we can just test set the time scale to 0 and it will just stop. I think it's more elegant to have like a boolean active equals true. So if current repeat count is greater or equal to repeat count, then active is false. And that's pretty much it. And here we can have if active just return. So when we have the repeat count, else we just ignore it, we just restart the animation over and over to infinite. And I think we could do the same. Wait, yeah, we need to do it for each type, I think. Could have some function actually, which can be protected. With update repeat count. Okay. And this will just update it for every one, so we don't have to copy and paste. Update repeat count. The ping pong, the repeat count. Actually, ping pong, yeah, it will be like 1, 2. So ping pong will be like this one. So it will be like 2 repeats. 1, 2. Yeah, it's okay. Alright. So basically it goes to reset active true. If it's yeah, this is okay. That's pretty much it, I guess. This is the animation. I guess it's okay. I don't see any problems, I think. We'll need to add some loaders and stuff like that, but I will see where we add that. That probably is here, maybe in the animation itself. Yeah, or maybe some loader. Alright, with animation, let's see in the unit to continue our animation saga. Okay, so we have animation. Actually, this is interesting. Should we have a animation. Yes, that's it. So for each instance of the unit of the sprites. So let's say that we have two sprites in a single unit, like this. So this is the unit, and we have two sprites, and they are instances because they have like position. So they have position and rotation and flipping and whatever. And we have animation, like they move in the unit itself. So the unit moves. Okay.